Hello, Dan Olds here on behalf of Hyperion Research and Inside HPC, and we have a great treat today. We're going to be talking to Suzy Tichenor, and we're going to be talking about where HPC and industry come together. How you doing, Suzy?
Hi, Dan. I'm doing great today. How are you?
I'm good. I'm good. Just going through these virus-riddled times and still shut in.
You're healthy, though.
Yes, like
Good.
a zoo
Good.
animal.
Good.
Just
Consider it a good day. You're healthy. You're blessed.
yes, and I assume you are too.
Yes, I consider myself very blessed. Thank
Yes,
you.
very much so. So tell me, how did you get involved with this HPC stuff?
Well, I began really in the Washington office of Cray, and I was handling a lot of their international trade issues. That really got me started. And I did that for a number of years working for Cray. And then
Okay.
I ended up at the Council on Competitiveness, which is a policy organization in Washington. And they had a very interesting project. They had funding from DoD and Department of Energy and National Science Foundation looking at high performance computing as a driver for economic competitiveness. And they were interested in understanding whether companies, whether industry was using HPC as aggressively as it could and should. And if not, why not? What were the barriers? And then what were there opportunities for public-private partnerships to address those barriers? What would be the role of the public sector and what would be the role of the private sector?
That's a big project.
Well, it was. I was there for 4 years running this, and it was very interesting. I mean, some of the key findings were that for the companies, we did a number of surveys, national surveys and conferences, and had a wonderful advisory committee of laboratory heads of HPC from the national labs, heads of of computing from and R&D from a number of companies. And so in these surveys, we found that for the companies that were using high performance computing, it was really essential to their business survival.
Sure.
But there were barriers to using it for them and even for newcomers. And they still exist, same things. I mean, you would find today also that companies who use HPC, it's really important for their business survival. But the same barriers are still around: lack of access to talent, or maybe not being able to afford to hire the talent. Ease of use issues, of course, as architectures change, that's always a challenge. So some of those barriers still exist. And then one of the really interesting findings that came out was kind of an aha moment. And I remember it in a meeting, we were talking about industrial use of HPC. And of course, this advisory committee was public and private sector people.
Sure.
And the public sector participants on the advisory committee had the impression that companies didn't have large-scale HPC systems because they didn't have big problems. Because, because the feeling was companies are for-profit entities, they invest where they need it, and if they had big problems, they'd go out and buy big computers. And so what the companies at the advisory committee said was, no, you have a misconception. First off, we all have big problems sitting on the shelf, but our business and financial model doesn't allow us to invest tens of millions of dollars in a computer that's going to be out of date in a couple of years. Our CEOs won't allow that. Our boards of directors won't permit that. So we have to wait for that performance to drop down into a lower price point so that we can jump on, which is why we're always drafting behind you. But we have big problems. And by the way, you've been talking about these great supercomputers that you have, and DOE gets access to them and universities get access to them. Why can't companies have access to them? And that was a big outcome of that project.
That's a huge aha moment.
Well, it was. And DOE in particular took it very seriously. And the first step was they opened up the Insight program, which is one of the pathways to get time on a DOE supercomputer. And the first year they opened it up, 3 companies applied. From our advisory committee, actually, and they were selected. Of course, it's all peer review. And we had a conference, a user conference that summer, and the director for science from DOE came and gave a talk. And he said that the highest rated application that year in the Insight program came from a company.
Wow.
And it came from Pratt & Whitney. And
No
of course,
kidding.
Pratt & Whitney, yeah. And he said, I have to be honest and tell you, I was surprised that it was the highest rated, but as I read it, it was no question why it was the highest rated. These are complex problems that need leadership scale computing.
Oh, yeah.
And so that opened up the idea that the DOE supercomputer centers should be more accessible to companies. And then
so a huge success case right off the bat.
Well, this was like at year 4.
Well,
I mean, not right off
relatively,
the bat. I mean, it took a long time. I mean, there were a lot of discussions that came out, all these findings. You know, we had surveys and conferences and meetings. The stuff doesn't just pop out at you.
No,
it takes time. And then you had to work with DOE, and DOE had to hit the cycle where they would open up Insight. So it took a while for this to happen. But then once that happened, the DOE lab started to say, well, how can we be a part of this? And so Oak Ridge actually was kind of the first there and stepped forward. They just made their own decision. They wanted to start an industrial partnership program for their computing center. And that's when I joined Oak Ridge.
That's what brought you down.
That's what brought me to Oak Ridge, yeah, to help to launch that and then to manage that. And it's been, I think, pretty successful.
That's fantastic. So looking back over the years, what are the biggest changes that you've seen throughout your career when it comes to HPC and industry?
Well, a number of things. First off, I think right now it's a wonderful time because there's a lot of opportunity to access high performance computing through different pathways. First off, there are a lot of opportunities at much lower price points than there were a number of years ago,
yes.
Right? There are smaller systems that you can have and bring in that are very powerful. There is cloud computing now. There's HPC on demand. That's hugely important.
That's a big deal.
Hugely important. And now at the top end, at the leadership computing end, you have the NSF supercomputer centers, they're open to industry, and you have the DOE user facilities at the very highest end. They've made their supercomputers much more accessible to industry. And I think that's been really helpful for a lot of companies.
And it certainly has been successful, a successful partnership, right?
I would think so. I mean, we're still doing it after 10 years here. And what's exciting is that we've seen companies start, I'm just speaking for our center, and sure. I'm sure the other supercomputer centers have their own stories. At Oak Ridge, we made a conscious decision when we started this that we would not have a set aside for industry, that industry was going to have to compete in each pathway. There were 3 different ways you could apply for time, but industry was going to have to compete in each one with everyone else. That we weren't going to say, okay, 10% of the system is going to be for industry, or 20% or 2%, or whatever it would be. They'd have to compete. And it was kind of hard in the beginning. I mean, they weren't used to writing the kinds of proposals that the DOE was looking for. There was a lot to learn. And we had to get, the DOE side had to get reviewers that were used to reviewing industrial proposals because they were different kinds of problems. Sure. And so, there were little stumbles along the way, but everybody worked with each other. And we saw companies come in and start with very small allocations through what we call our director's discretionary program, which is where companies come to kind of get their feet, anyone comes to get their feet wet and kind of to prepare themselves for some of the larger calls for proposals. And we've seen companies move successfully now from those smaller allocations over several years, then to the ALCC program, and then to compete successfully for Insight. And so it's been really exciting because companies are growing in their experience to apply high performance computing to real world problems. And they're growing in that experience through access to the DOE systems. And that's a wonderful contribution to competitiveness. Oh, yeah. It's great. And then as those companies are progressing, they're also then upgrading their own internal systems because they realize they can't go to DOE for everything, right?
Yes.
But as they get their feet wet, then they go back, and now they've built a real ROI case for the CFO.
And that's key to convince business management to invest the money.
Right. Because they'll bring that test case out to a larger system at the DOE center, and it'll be a proof of concept. And they'll show what they could do if they had access to more. And then they can go back and use that to justify an upgrade. Now, they're probably not going to upgrade to what DOE has, right? I mean, they don't have, but they can do a big upgrade anyway and do more internally. So that's been really helpful, because ultimately it's helped to seed the market too.
So Suzy, artificial intelligence, AI, is all the rage right now.
Yeah.
How can that work out for a private company that's looking to get their feet wet?
Well, this is a very, very exciting time in high performance computing with the new systems that are coming out. And I can tell you that at Oak Ridge, the Summit system that we have is really uniquely architected to do not only the traditional modeling and simulation that you think about car crashes and airplane design, but also very large scale data analytics, deep learning, and machine learning. Summit is just wonderful for that.
Yes.
And so we see companies now applying for time with us, not to do the traditional mod sim, but to really start to learn and perfect their AI models, learn about and perfect their AI models and how to do that at scale. And we have, interestingly, a lot of small companies and startups that are in that area that are very capable of using a very large system like this and who would benefit from access. You know, one thing we learned, Dan, from our program, industry program, is that large-scale computing is not the purview of large companies. A lot of large companies are, you know, at the beginning of their HPC journey. And there are a lot of very small and nimble startups who are very capable of using large systems, but they just don't have access to them, right? They can't afford them. And so we're agnostic as to the size of the company that wants to come and use. We're always looking at what's the science and what's their ability to use these systems. And now, especially in the AI and machine learning area, we're seeing there are a lot of small companies out there that could very much benefit from coming to a center like Summit, center like OLCF, and use a system like Summit. And I think that's going to be a big trend in all the DOE supercomputing centers, seeing a lot more machine learning and artificial intelligence and data analytics being done on these big systems, and then being done also in combination with physical, you know, data from physical experiments too.
Sure.
So it's really a very exciting and broadening time for the use of high performance computing with these new architectures.
It's interesting. I did an HPC road trip last year. I drove from Portland, Oregon down to Dallas, Texas for SC, but I stopped along the way at National Labs on the way down and on the way back up and did interviews, and almost all of them said that they're going to be using, and maybe heavily using, AI to inform their simulations.
Yes.
So definitely on the cutting edge, and that was nearly 2 years ago.
Yep. And now we have systems that can do that at scale.
Yes.
Because when you think about the simulation data, it's enormous.
Oh, huge.
You know,
huge.
Right. So you need, you know, enormous systems like a Summit, like the exascale systems that are coming, in order to make sense of all of that in a reasonable amount of time.
That's fantastic, giving them a window into AI.
It's really a crystal ball look.
Yes, absolutely. And who couldn't use that now?
I don't think anyone would turn it down if they had the chance.
Now, we've talked about what has you excited, and it's obvious that you're excited about this, and you still are over the years.
Yeah. Working with these companies is awesome. Their problems are exciting. The people are excited to be working on them, and they're real world problems. They're now problems. Whereas a lot of the research is fundamental research that goes on at the user facilities. And so you might not see the practical application of some of that for years down the road. Whereas companies, of course, have a different business model, right? Their research isn't just for curiosity.
No.
It's very much aligned with a business objective.
It's going to have an impact right away in a lot of cases.
It needs to, or they can't justify it.
Yes. Now, is there anything that has you concerned looking forward and looking down the road?
Concerned, that's a really good question. Um, I tend to take a longer view and say that these things work themselves out over time.
Sure.
But in the nearer term, we don't see companies jumping on to GPUs as quickly as of
As they
course
should.
as DOE has. Well, as they should. You know, that's a business question. There is a cost to making that move. There is a cost if you have your own internal software. There's a cost to porting it. And then a lot of companies are still very dependent on ISVs, right?
Yes.
ISVs are going to port their software as there is demand. There tends to be more demand at the higher end, which is, you know, the peak of the industrial pyramid, which is smaller than the
Yeah.
base, which might not be demanding it quite now.
Well,
So
that'll also lead to higher ISV costs if they're doing it for a small number.
Well, that's right.
They will charge whatever they can get.
So there's that, you know, what will the market bear? And so there's a lot of that. But for companies that are still writing their own internal software, they're moving along a little bit more quickly, and that's gratifying. And we're starting to see that now. It's important for companies that have been using the DOE centers as a springboard to an early attack on large-scale problems that they can't solve on their internal systems. Mm-hmm. It's really important for them now to seriously think about GPUs, because you've seen now the announcement of the exascale systems.
Yes.
They're all going to be heterogeneous architectures.
Yes.
So if a company has been using DOE systems for their larger scale problems and they haven't been able to port their software yet to GPUs or find a substitute open code, they're not going to be able to use those DOE systems until they do.
It's not going to pay off for them at all.
Well, they won't. They won't. You won't be able to get your project. In most cases, the project just won't be accepted. It won't be approved, right? Because the horsepower is coming from the GPUs. So it doesn't make sense if you
about 90% or more of the horsepower is coming from the GPUs.
Yeah.
So they need to be able to jump on. They need to be on the train.
Yeah. Now, one thing that the DOE labs have done that has been very helpful is they started a few years ago hackathons where organizations can bring their code to a week-long intensive workshop. It's all free. You just have to pay for yourself to get there. And then we have experts from the labs and the vendors there to work with you to get that code ported over and get it started. These have been very, very successful, and we have found ways to work with proprietary code too. With companies can bring mini apps, and it's been successful. We've had some companies who've come in with their own codes, and that's worked well, and that's given them a jump. So there are tools out there and training and workshops that can help. But as far as a concern, I guess my concern would be that more companies see the importance of moving to GPUs. If they want to scale up, because that's where the big systems are.
Yes, and that's a little bit of a surprise to me, because I know that as an industry analyst, I've been talking about and promoting the use of GPUs since 2008.
It took a couple of years before people realized, wow, there was a real benefit to that. And I think that's, you know, now you see all the exascale systems. So I can, that will be with GPUs. So I can understand companies sort of holding back a little bit to say, before we take the plunge, an expensive plunge, let's see if it's really going to pay out. And, you know, that's one of the important roles that DOE plays. It's the early adopter. It's where you find serial number one in the hardware, right?
Absolutely.
DOE helps to push and prove out the technology. And so I can see why companies have waited to see, well, let's see what happens. Is DOE really going to do this and stick with it? I think the answer is a resounding yes.
Yeah.
And so it's really time, if you haven't done it already, that you need to do that. Or you're going to be locked out of certain things.
You know, one thing, and I imagine these tools are out there, but I'm not sure specifically what they are, but do you have something that you can give to a company that says that, you know, these applications will have X type of acceleration using accelerators? Like
well, we don't have a fact sheet that has that, but you can certainly there's information on websites and you can find out. I mean, if they have a code that they're interested in, an open code, we can certainly tell them, has that ported over to GPUs yet? And you know, they can send us an email, we can tell them that, or they can just, if they're working with an open code already, scientific code, they can just go to the community, right, themselves and find that out. And DOE has made a lot of investments in porting a lot of community codes that are important to the DOE at least, and that are used by other researchers, that they're porting them to GPUs. So some of that work's been done. But you know, not every company uses open codes. A lot of them use commercial codes because there's a lot more support there. A lot of them use, you know, still have kept the secret sauce internally and use their own.
Well, this has been great, Suzy. Thank you so much for your time. It's been a real education for me, and I'm sure our audience is going to listen with rapt attention.
Oh, well, I don't know about that, but let me just close by saying, if there is a company listening and you have some large problems that really exceed what you can do internally, don't hesitate to get in touch with us at Oak Ridge, one of the other DOE labs that has an industry partnership program, and see if there might be an opportunity for you to bring that problem to a DOE center and get some advanced notice, you know, get an advanced chance to start working on it before you run it internally. It could be a great opportunity.
That's great advice, and I hope everybody out there follows up on it. I'll see if I can come up with a problem here and send it to you. Thank you again, Suzy.
All righty. Thank you very much.